All right, started recording. So to make sure that you're okay with the tools that we're building and understand how they use how they might be used. All right. So without further ado, I'll switch over to Hyatt. Dr. Green, you can
Yeah,
go ahead with your presentation. I just allowed screen sharing there. And
thanks,
so
Dave.
so during your presentation, I'll keep an eye on the chat, and I think let's take questions about the analytical method after this. If anybody has any questions about the microbiology, and I'll just say Dr. Hyatt Green, he's an expert in environmental microbiology, and so he's been instrumental in developing um, the analytical methods that are needed. So over to you.
Yeah, thanks, Dave. Yeah, so I'll just give a quick overview of the methods, without going into too much detail, I hope. And like Dave said, if anybody has questions, let us know in the chat box. But um, first, can everybody see the slide there? Okay. So I'll just give a quick overview of the two main points, two sort of methodological features that we're using to collect the data from wastewater. That's the ultrasucrose method and the use of phage as a population normalizer. So there are other methods out there to pull coronavirus RNA from wastewater. We developed this method along with Frank Middleton at Upstate Medical University in order to meet what we thought were the sensitivity requirements, but also the scaling. We developed this method with the intent of being able to scale up to hundreds or thousands of samples per week. So this is an ultracentrifugation based method, which means it's dependent on the size and mass of the particles, which, as you can imagine, are extremely variable in a substance like wastewater. A lot of variability. And we're assuming that the viral RNA that we're looking for is attached to those larger, heavier particles. If it weren't, we probably wouldn't be able to detect it that well. And so our goal is to concentrate all of the viral RNA, like you see in panel B, down to the bottom of the ultracentrifuge tube, while leaving behind a lot of these low density contaminants that tend to interfere with the method. So we can concentrate about, we've actually improved our the number of samples that we can analyze and the volume we can analyze. But when this image was taken, we were concentrating about 6 samples at a time, about 20 milliliters per sample, down to about 200 microliters of 0.2 mils in about 45 minutes. And so if you do the math, you have a few shifts. That means that we're working up right now to have a capacity of almost 2,000 samples per week with 4 ultracentrifuges. So we're pretty happy about the ability to scale up that large with this method. It also avoids filter fouling or just clogging of the filters, which is a problem that you will run up against with other slower methods like tangential flow filtration. And as you can tell in the image here in panel A, we're just putting in straight wastewater into the ultracentrifuge tube and then putting a sucrose solution, 50% sucrose solution right underneath that wastewater. And this is no different than the sugar that you may have put in your coffee this morning. So we're loading that. There's no pretreatment of that wastewater sample before it goes in to the ultracentrifuge. So the overall workflow, we're taking in a wastewater sample. Very early on when this image was taken, we were taking in liters of wastewater. We don't really need that much anymore. So just about 40 or so mils at a minimum. And that is loaded into the ultracentrifuge tube, ultracentrifuged, 6 samples. Like I said, we've now increased that to 8 samples. We've got a new rotor that's doing 8 samples per spin. for about 45 minutes. And then we end up with a pellet down at the bottom, and you can see how nasty that pellet is. Like it still has lots of impurities in there. So we have to take that then through a DNA and RNA purification kit because there's still lots of cleanup that needs to be done to go through the PCR process. We'll then take that to basically from here out, it's the same test that's done if you've got a nasal swab done before or saliva swab for SARS-CoV-2. It's the same, pretty much the same process from that point on. We test the purified pellet for both SARS-CoV-2, and then something I'll talk about in a minute is crassphage DNA and crassphage RNA to act as a population normalizer. And then we do, of course, the data analysis, which Dave and Mary will talk about. So the big question is when you get SARS-CoV-2 concentrations from wastewater, you have the immediate question, and if you've looked at this data before, well, what do we make out of it, right? How do we interpret these concentrations? And one of the big questions that people are having is what happens to that viral RNA while it's in transit from when it was flushed down the toilet to when a sample was taken? Because we know that a lot of things are happening in that system that dilute or decay or that degrade the exact RNA that we're looking for. So you can have dilution through things of people taking showers, that gray water that's mixed in, that's diluting the RNA that we're looking for. Stormwater, so in combined systems where stormwater is also treated, in some cases, depending on the magnitude of the storm, stormwater will serve to dilute the RNA that we're looking for. You can also have various industries that input a large amount of water or other things into the wastewater that serve to dilute the RNA that we're looking for. And of course, I&I, so maybe faulty infrastructure that allows groundwater seepage into the infrastructure that again serves to dilute what we're looking for. And at the same time, this virus it's a very weak virus. It's an enveloped RNA virus. So we think that it breaks down very quickly. We also know that RNA that's released from the viral capsid is also very labile and degrades very easily. So how do things like changes in temperature when it warmed up from March and April and throughout the summer, how did that increase in temperature either speed up, probably speed up, but how did it affect the decay of that RNA? What about changes in pH? Did those have some effect on the decay of the RNA? And those things, those changes in the wastewater infrastructure between sites, we need to know the effects, the relative effects of things like temperature and pH to allow us to compare RNA concentrations between sites, between places. And then you also have industrial inputs that could affect the various compounds that are output from industries, from very specific types of industries that could degrade RNA. So how do we do this? And of course, you can put a bunch of sensors all over the wastewater infrastructure system and take measurements and then model, basically build a model of how decay is happening or how dilution is diluting RNA throughout the system. And that's certainly a valid method. But that has its downsides. And so we've gone to using an organism which has a pretty funny name, considering that it's excreted from the human body, cross-assembly phage or crassphage. And it's a bacteriophage that infects members of Bacteroidetes, meaning that it is very abundant in your gut. So it is a double-stranded DNA phage, not an RNA phage like coronavirus. It has a head plus a tiny tail there. and it's very widespread. So it's found in about 38% of humans at over 10 to the 7th per gram of feces. So that means it's probably one of the most abundant microorganisms associated with the human body. And then really conveniently, the EPA has developed a qPCR method to target this organism, both specifically and sensitively. And so we were just able to pull this assay, this test right off the shelf and integrate it into our methods. And so our question is can crassphage be used as a population denominator to account for those things like decay and dilution that affect RNA, the coronavirus RNA concentrations in wastewater. At a minimum, it can also be a quality control. So if we can't get RNA out of this organism or DNA out of this organism, then we know we're probably not going to be able to do it with SARS-CoV-2 either. So it has a couple different functions that we can use it for. And so this is just a diagram showing basically the same thing. You know, SARS-CoV-2 is infecting a human cell. Those human cells are very weak in wastewater. They're going to lyse fairly quickly, we think. RNA is released. That RNA is going to go through decay and dilution processes, and then we're going to see it at the end. And we're just using crassphage. It does have a bacterial host, so it's a little bit different than a human cell. We're using crassphage RNA or DNA in the same sort of way as a surrogate to accumulate those effects in the same way. And the hope is, I don't think the data is quite there for this yet, but the hope, you know, is that we're able to take the SARS-CoV-2 concentrations over the crassphage concentrations and have that be somewhat proportional to the degree of community spread on the ground. But, you know, Dave and Mary, you guys probably looked at the data a little bit more, but what I've seen from this past summer is we're not, I don't know if we're quite there yet. We do know that, and this is the last thing I'll mention, that crassphage concentration increases, and this is what we would expect. We see an increase in crassphage DNA, which is the top line there, and crassphage RNA increase as a function of the population that's represented in a particular service area. So the more people that are represented per gallon of wastewater, the higher the amount of crassphage that we see. So there is some evidence that it's while there is some variability, there is some evidence that it is doing a pretty good job at being a population normalizer. So that's all I have. Dave, I think you want to go next?
Yeah, I can go next. Thanks, Hyatt.
Yep.
We did get one question from Kendra. She's asking about a comparison between crassphage and peppered mild mottled virus, PMMOV, as a fecal indicator, and if you've run any of those comparisons. Yeah, no, yeah, PMMOV is another widely used surrogate for basically to do the exact same thing that we're doing. And we looked at PMMOV very early on in March, you know, to act as a population normalizer. The thing that, and the reason, and the other advantage of PMMOV is it had a microbial source tracking assay ready to go. So we could have easily pulled that one off the shelf instead of the crassphage. The one thing that we didn't like is that despite it being an RNA virus, it is shown to be very persistent in the wastewater infrastructure and very persistent even through the wastewater treatment process, despite it being an RNA virus. And so we thought that really didn't really reflect the situation with SARS-CoV-2, which is very labile and, you know, as an enveloped RNA virus. Then a question from Wendy Gilbert from RIT. How do you ensure that the 20 milliliter sample used for testing is representative of the entire sample, or of the entire population that would be
Yeah.
sampled?
Yeah, right. And so that's, that's a tough thing to do because you have a larger wastewater sample. And even within that, 200 mil sample, 250 mil sample, whatever 20 mils you take out is going to be somewhat different than that. There are different ways to homogenize that. But I think shaking is what we're doing now. We're shaking before we take that subsample out.
Yeah, and I'll just add that the sample that we use, we encourage a 24-hour composite sample.
Yes.
And so there is random variation in human toilet use behavior, but with the sampler that pulls a little sample of wastewater every over the course of 24 hours, that sample can be representative of the population. Question from Amy Markowski about any effects of chlorine on detecting COVID from chlorinated municipal supplies.
Right, that's a great question because chlorine is certainly going to have an effect on the ability to detect RNA. At least it does in the lab. We haven't run any good experiments to test that, but that is interesting. Chlorine should affect. I mean, at high enough concentrations, that would accelerate the decay of RNA. But I don't know. It depends on the concentration. So it depends on the dosing. If chlorine's not added at high enough concentration that if it was diluted so much, then it's possible that it may not have an effect on that RNA. But that's a great question. We haven't run any really controlled experiments on that.
All right, so I think that's all the questions. Thanks, Hyatt, for the informative discussion of the detection of RNA. We'll now switch over to me for an examination of understanding the data that comes out. Sorry, I'm just trying to get into full screen here. All right, so I'll talk about what we've learned so far. It says sharing is paused. Did everybody see on my screen? No? All right, well, we can see this one, I imagine, right? So I'll talk about what we learned so far with the work that we've been doing around early warning wastewater surveillance platform for New York State. And to give a bit of background, the goal of this was really to develop a product that New York State could use as a whole and to help the state respond better to the pandemic. And so this, it's a four-step process. The wastewater has to be sampled. It has to be analyzed, which Hyatt's discussed. And then the data from the analysis has to be informative in some capacity to inform on transmission trends or to give understanding of the epidemic. And then the local health departments and the public would then respond to the data. And so I'll talk a lot about this classifying transmission from wastewater and a little bit about this earlier targeted intervention, though I will say that this is perhaps the next piece that needs to be understood better. And so as I go through the early warning we have, I'd encourage you to think through, well, what would you do? What would you do with the early warning that we have? What interventions might we apply? And I'll give some ideas myself as well. So I'll give a little bit of background and then I'll go through 5 different analyses. And then I'll give a recap of the usefulness, right? And so background on our project, Hyatt, Mary, and I, we represent 3 of 20 or so scientists working together. And we've come together in March, April, and then people have joined in, right? And we're all working with the same goal. It's been a really interesting and fulfilling endeavor, though I do wish that it hadn't happened during the crazy pandemic that we're in. Right, we started in March, And that's when the proof of concept was established that you could pull coronavirus RNA out of wastewater. And that the idea of monitoring infectious disease transmission from wastewater is actually pretty old. It was used wide scale in the 1990s in other countries to understand polio transmission. And so that was our eureka moment for our team. You know, we saw that and said, all right, let's do it. And we secured some seed funding from Syracuse University and SUNY ESF. In the month of April, working with Onondaga County, the county personnel, the wastewater personnel, pulling samples for us and us testing things, and a lot of frustrations, I'm sure, with us not trying to figure out the methods. That's when the method was developed that Hyatt gave the overview. And we're averaging about 8% viral recovery with this method. And it's 8% is actually better than most other methods. We then began scaling, expanding beyond just Onondaga County. And then we partnered with a biotech company called Quadrant, and they took over, the fee-for-service aspect, because we're, Hyatt, marry us, the universities, we're not a business, so it doesn't make sense for us to be in that. And so they took that over and started scaling up throughput. We had conversations with the state health department, and they agreed to do a pilot in July. And they chose 4 different cities to continue going in Onondaga County, to add in Albany and Buffalo, and the city of Newburgh and Orange County. And that began in August. And we, in September, we had a methods improvement where we went from 8% viral recovery up to 40%, which is a big piece. The pilot, we finished the sampling in mid-September, and now we're just finishing up the modeling. And so at the same time that we're presenting this to you, we're also pushing the state to adopt a statewide platform and a statewide coordinated effort around wastewater surveillance. And here's where we're working so far, or currently. Previous to the end of the pilot, we were in Erie, Albany, and Newburgh and Orange County. And these blue dots represent different universities that are working with us. And so going through this understanding, it's informed by not only the state pilot data, which are a little bit more robust. We sampled every sewer shed was sampled 3 times weekly. But then we also have a lot of insight from others where it's twice weekly or once weekly. And in the context of trying to prove out the science that this works as an early warning, with only seeing a rise in transmission statewide occurring since maybe September into now. And this further gives us context of, well, why might this be useful? It's in the middle of a pandemic, we're already handling things. And unfortunately, transmission's on the rise. And as long as we keep schools open and try to keep our businesses open as much as possible, which I'm a big proponent of, safely and doing that, then we will have an increased risk of transmission because it just increases contacts. All right. So the first piece of information that you get from wastewater is you get a qualitative category of how much or whether SARS-CoV-2 RNA was detected, and then how much. And so these different categories are, we didn't detect coronavirus RNA in the wastewater. That's the first category. We did detect it, but it was below the level of quantification. And then the third category is it was at quantifiable levels. And using our older method, about 8% viral recovery, we can see that there's clear delineation in these categories with the number of cases about a week later. And so not detected, we were averaging about 2 cases per 10,000 population a week later. And so we think about that from the epidemiology standpoint as a limit of detection of the previous less sensitive PCR. But then that's qualitatively different from detecting but not quantifiable, and quantifiable is the highest. All right. Since September, we switched over a 5 times increase in the sensitivity, and we're getting detections levels about 1 case per 10,000 population. And so, and there's there's variation in this, right? These are reported cases, so this doesn't maybe underestimate the number of infections, because these are cases that are reported through the state health system. And there's a couple things that'll influence whether a single case actually is detectable through wastewater. So the first thing is that only about half of coronavirus infections shed RNA in the feces. And so we're not looking at identifying just single people, we're looking at groups. The second one is that there's random variation in toilet use, right? People use a toilet when they need a toilet, and if they're at their house, they'll use that toilet. If they're somewhere else, they may use a different toilet. And so when we say we detect about 1 case per 10,000, that's on average. You know, that we're getting significant detection here. That's the average detection, about 1 case per 10,000. So we're comfortable with the method to identify small changes in transmission. And I'll kind of go over those in a little bit. Right. We've worked with a few different SUNY schools and also the communities, the municipal wastewater treatment plants. And we've observed that we had an early warning at three different communities. So SUNY Cortland, SUNY Oswego, and SUNY Oneonta in Otsego County, all three have had significant outbreaks of coronavirus, right? And the question we asked, well, did we have an early warning from wastewater that signaled to them that something was going to happen? And when we look at this retrospectively in Cortland and Oswego County, we did, right? Where in Cortland County, we had just non-detection of coronavirus for a long time. And then right before September, a detection here that went from non-quantifiable up to quantifiable, and that precedes the rise in cases in Cortland County in mid-September, early September. In Oswego, we had kind of some variation, you know, if we go back through July, some variation of detected and not detected, and then it just jumped real high up to quantifiable, right? And that precedes the large outbreak that occurred at SUNY Oswego. Now these were identified retrospectively, right? Because we don't have the tools yet, and that's what we're talking about, the tools that you can respond immediately or prospectively. SUNY Oneonta was actually able to respond to the wastewater immediately, right? They had a detection in the wastewater at the county, at the municipal level, at the community level, at their treatment plant. You can see that they saw the rise here that preceded this spike. What I'm not showing is at the university, they had a detection on August 20th, which prompted them to quicken accelerate their mass testing plan. They planned mass testing for their students in a few weeks, and they just accelerated it to do it immediately following. And that's when they uncovered the large, widespread outbreak that they had. And they likely prevented a number of infections by responding so quickly. And so we're comfortable in saying that at the community level, we have a very good early warning system going from low levels of transmission, near non-detection in the community, and then jumping, that signifies that there's going to be an outbreak in some capacity. Right. At the same time, the question is, well, what about those communities where there's a little bit more transmission established? You know, in some of the larger cities across upstate New York, larger cities always have more transmission than the smaller rural towns, just because of the nature of social mixing and things, the distance between neighbors. And so the question is, can we make a tool that's useful for these other communities and counties? And so when we look at the percent change in cases in coronavirus, and we correlate that with a trend line that we'll talk about in the dashboard, then that trend line is actually highly correlated with the percent change in cases a week and 2 weeks later. And so for major wastewater treatment plants that we've worked with that account for a majority of the county population, if we use a 1 week trend model, then we have about a 50% correlation up to a week in advance of cases going up or going down, percent changes in cases. And then the 2 week trend model kind of peaks at about 3 cases or 3 days, right? And that's the same whether we use RNA in these ones here or DNA in this one, the crasphage, how we standardize the data, right? And we'll be updating these analyses with sewer shed specific analyses once we have the data all matched up and geocoded on the state cases. Now, when we use what we call a county harmonization model, right, where we try to take all the wastewater surveillance within a county and we create a county trend, and then we look at how that correlates with county cases, we see some really significant correlations on the 2-week trend model, where it's correlating about a week out, 5 to 6 days, with a correlation coefficient of about 0.8. And that's with, RNA or DNA, however we standardize that. Now, the 1-week trend, it's a little bit less, right? And there is sampling variance in wastewater, so we do get a little bit of a spiky trend. And so 1 week's not as good as that 2-week trend. Right. We can also do some trend analytics on the wastewater data that we have. And so this shows some data from one of the treatment plants and the cases there, right? And an increasing trend, and we can build in these cut points, and we're working on this over the rest of this calendar year, build in these cut points where if the trend changes by about 45 degrees is what our colleagues did here. Once that trend changes, you can get an alert that says, hey, the trend has shifted. You think about going through a rise in cases, and then you get an alert that says, we think the trend has shifted, and then it to come down, and then it's down, and then say, oh, we think it's going back up again. And the ability to message that not only to your team, but to the public to say, we're probably through the worst of it, let's keep going, really good job. Or to say, hey, we've got to brace ourselves for some transmission that's coming, so let's hunker down. And we're trying to really get these social distancing interventions compressed in time, right? So they don't have to be, we shut down, I think it was March 20th, and my kids were out of school through May 20th or something, or they were out of school for the rest of the year. And so that 3-month-long social isolation intervention, if we can intervene more quickly and know when the transmission is gone, we can actually lift that more quickly and respond to transmission dynamics, right? So the quicker we respond in terms of when transmission is increasing, the shorter that response can actually be with some of these social distancing events. And that's only one of the interventions that you could bring to bear in the coronavirus pandemic. Now, one of the analyses that I like the most from this, especially working with Syracuse University at the dorm level, but then also it applies to communities, is when we get a negative result, when we actually don't detect coronavirus. Now, we're pretty confident that we can detect coronavirus when there's 1 case in 10,000 people. And so that negative result actually is meaningful to say, we don't think the transmission is significant in this area, and it may even be absent. And we can use repeated negative results to give a probability that's actually under control, coronavirus transmission is under control, right? And to be able to feed confidence back to the population to engage in the economy, to be safely engaged socially and different aspects. And the pandemic will last as long as the people are not willing to engage, basically. As long as the people are afraid of coronavirus, the pandemic will last. And whether that happens because we control it through contact tracing and isolation and quarantine, right? Or if we wait for a vaccine. But this can give us confidence that, yeah, this community is actually doing really well and has coronavirus under control. So each of these different points represents a new wastewater sample. So in Cayuga County, at one of our treatment plants, we had repeated detected coronavirus RNA, and then it was not detected, but then it was detected again. So there's no probability that there's an absence of transmission or that it's controlled to that point. But then we get a non-detection and a repeated non-detection, and each subsequent non-detection raises the probability that it's under control and even absent. And so this is a function not of calendar time, but of how frequent its sampling is. They sample weekly over there. And so it takes a few months to establish 75%, 80% control. But if you sample twice or 3 times weekly, then you can establish that in a few weeks, right? Now, once you detect it and you have that early warning, it comes right back down. And that's what's happened over there is they've had that a little bit of a rise, probably tied back to the schools opening. And the same thing in Cortland here, where it's increasing probability that it's absent, and then a little bit of a spike where it goes away, and then or where the probability drops to 0, and then it goes back up until another spike and it drops back to 0. And so a bit of a recap, would wastewater surveillance improve pandemic response in your county, in the state of New York? I tend to think so. I think it's a huge effort, or not a huge effort, but a huge value proposition. So one, if you have a week's warning of where transmission is increasing, then you can have strategic allocation of finite resources. So that could be people's attention, personnel, tests, tracers, future vaccines. The other thing, it could be the public response to say, everybody social distance, right? That's a finite resource. We can't rely on the public to stay socially distanced forever until we have vaccines. I think that's just too hard. And so if we are able to guide them and prompt them and say, hey, it's on the rise, be extra vigilant today, that's helpful. We get confidence that transmission is under control or even absent, which is a huge value proposition for smaller rural communities. And it'll be less of it'll come into play a little bit less in the larger cities because there's more transmission just naturally. We have a clear early warning about a week for when it does come back, because the risk never goes away as long as we have a mobility across county or across communities and across county lines and state lines. We have an easy glance at the state, and Mary, Dr. Collins will go over that. One of the, from a behavioral health standpoint, like one of the primary drivers of people engaging in healthy behaviors is the perceived risk of the thing they're trying to avoid, right? And so my perceived risk of coronavirus can be better informed by my local understanding of transmission. So if I know that my neighbor, and this actually happened to me, we didn't socially engage for months and months. And then we had a neighbor over for dinner, right? And we did so safely, not out partying, but just a neighbor over for dinner. And then that person got put in quarantine. And my behavior changed immediately back to hunker down mode, right? Where it's like, all right, they're in quarantine. We're a low grade exposure. And so that's a local understanding of transmission. And that's on the individual person to person scale, but on a community scale, when you're able to relate transmission back to neighborhoods and say, in this specific neighborhood, we've had a rise in transmission, then that can drive engagement in social distancing and mask wearing, right? In the future, as vaccines begin to come online, there is a lot of public skepticism about vaccines, I think it's fair to say, given the climate that we live in, the political and the partisan climate that we're engaged in this country. The wastewater can actually help to understand that vaccine is effective. As the vaccine rolls out through a community, we would expect to see the transmission just drop off. And the first identification of that would be a decline in the wastewater RNA levels. And that can be fed back to the public to pick up as well. All right. And that's all for me. I wanted to just mention that, besides the 3 universities, we've worked really well with Arcadis, who've helped to pull samples and inform. They're expert in wastewater sampling and beyond the counties. We had a great partnership with Onondaga County, or continue to have a great partnership with Onondaga County, and there are other counties that are involved. And then Quadrant Biosciences as well. All right, let me check the questions. So no questions from mine. And so I'll push over to you, Mary.
Great.
You take the next bit.
All right. So building off of what Hyatt and Dave have presented already, the point of the dashboard here that I'm going to show you in just a minute. Let me see if I can get my screen. Do you see my screen? Cool. So the point of the dashboard, right, is to take all of the the RNA identification science that's going on and all the methods that we've developed, the science, take the modeling that Dave just talked about, and try and help with decision making, at various scales. So what I'll show you today is the dashboard as it currently exists. It is, the main purpose really here, it would very much help us to get some feedback. And as you listen, thinking about, what things are missing, what decisions are you facing that these data might help you with? And I guess the use case that I have in my head is, and how we've developed this, and I worked with a grad student of mine on this. We envision the use case kind of as like, okay, there's somebody who's going to check into this on a regular basis. There's going to be seamless updating on a daily basis so that, part of your routine could be logging in and checking out what is going on. And again, we are interested in making this public. And right now I have shared it with a few folks, but it's all private at the moment. So what this dashboard is doing is providing a visualization of the trend analysis that Dave was talking about. So we're using the 2-week trend here. And at the end, I'll talk about sort of where we're going with this in the context of potential innovations. But this is the, sort of the beta version, I would say. So right here we have the 2 New York State maps, and I'll tell you a little bit about them before I start clicking around. So all of the counties that are gray are counties that aren't participating in the wastewater sampling project. And any county that's not gray is participating. And we have 2 maps here. One is the alert level map. And the alert level map ranges from dark blue to dark orange. Dark blue is a decreasing trend over the 2-week sampling period, and dark orange is an increasing trend in the 2-week period. And if if regression coefficients speak to you, this is the slope of the line across 2 weeks of data, the beta coefficient. But we're trying to, continue to hone our language. We have a little bit of information down here that'll help, but before I get to that, so the second map here is our level of confidence associated with the alert level that we're communicating. And so this ranges from the low level confidence, which is the white, to higher level confidence, which would be a 1. And analogous in a regression model would be something like the amount of variation that is explained in the response variable. So in this case, it's the detection, the cross-phase normalized detection. So it's population normalized detection of SARS-CoV-2. So these are county level harmonization models that I'm displaying. So you can hover over any of these counties and you can see, Madison has a little bit of an increase here. Onondaga's pretty flat. But what we've also done is allowed for, you can click on any one of these counties. For example, I'll start with Madison here, and then I'll click on another one. And from there, you get to some of the more granular data. We've talked a lot about how we are collecting data at, obviously the sub-county level and sometimes even sub-wastewater treatment plant level. But in Madison County, we're collecting information at the village of Cazenovia as well as SUNY Morrisville. And this is the 2-week detection trend for the entire county. But you can click on, for example, you can click on Cazenovia, and you can see that while they have about, their slope is pretty flat. It's pretty flat because there was a downward trend earlier in October, but we had a spike happen on the 13th, which was just a few days ago. So before I get to really interpreting this, because part of some of what I think would be helpful to us, I have an idea of the types of decisions that people who might use this, or counties or officials who might use this. I have an idea of the types of decisions that might be made. And they certainly range from we see a spike, and so maybe we should increase testing or we should target something. But it includes what Dave was just talking about related to, you know, if there was a high probability of no transmission, then like you might make localized decisions that people could be more confident about. So keeping that in mind. But another county that I'll click on, so I'll click on Onondaga here, which has a more complicated catchment system here. So here are where we're, you know, doing sampling. We have decreases in the northern side, and I can, you know, I don't know, I'll click on Oak Orchard. You can see that it's decreasing. We have high confidence in this region. But we do have an increase on the 7th, which I guess was about a week ago, out in the eastern suburb here. And these are, you know, we've stopped short really of providing full scale, like these are the types of actions you might take when you see this type of rise, because that's just where we are at in development right now. I think that we would really like to make it full circle with especially input from people on this call about, you know, well, you know, what are the lessons learned from previous spikes, and how do we really help make sure that both this is a usable system, that the data are updated regularly or daily really, and then, you know, what types of responses might be helpful. You know, most of my other work is in pollution abatement at industrial facilities, and we do a lot to look at like, okay, well, this facility had an issue, and this is the action they took, right? And how do we make data usable so that decision makers can use it quickly and have confidence in it. So maybe I'll stop and see if there's any questions before I continue on, unless there is something that I'm missing. Let me see here.
None have come in yet, Mary.
I thought I saw something. Okay. So I think, yeah, I mean, that's where we're at right now with this dashboard project, and I'm happy to answer any questions or anything that you want. I mean, I think that, I guess just to reiterate where we're at is really trying to make this a daily, you know, a place to go on a daily basis to see how it's going in your county, and then, you know, link up with decision making. And I echo Dave in the sense that, you know, the probability of no transmission could change local decision making pretty substantially. And as a person with a toddler that likes to go to playgrounds, you know, if I saw 0 transmission, and, you know, I might be more willing to even do small things like that. So.
Mary, Gary Brown, Merrill County.
Hi.
So how are you? So that's 0.5, the alert levels, that's a 50% increase in detection in the wastewater?
That is, it's a, yeah, it's a 50% change in the sort of the regression slope. The units of that are, well, I'm not exactly sure if it's a 50% change. I'd have to look specifically at whether, I don't think it's a 50% change in actual detection. It's a 50% change in the sort of slope of the line.
So, but down below it says first map 0.1 indicates a 10% increase in detection.
Yeah, we should probably hone that language a little bit. So it's, I would have to look back at that and make sure that it's, you know, crystal clear. But it's a change in the standardized coefficient that describes the change over time.
And right
but
now,
that's a good point to make sure it's clear.
and right now, Gary, those coefficient numbers are it's just kind of like increasing or decreasing. Once we get the data dump from the state, we'll put some values behind it to say, you know, a change in coefficient led to this % change.
Yeah.
Right? And so these are So we're
Data
getting-
dump, what kind of data dump from the state, like cases? Data dump from the state, what does that mean?
So that's the case data matched up to the different sewer sheds that we have.
Okay, I guess I understand.
Okay, Steve asked, okay, so Katrina asked, will the dashboard be owned by SU or by New York State Department of Health? Well, I don't know. Dave, what do you think about that? I mean, at this point, I don't think this specific effort isn't part of the DOH.
So the DOH didn't pay for this, and
Yeah, this is just.
And just
yeah.
to clarify, you know, SU is one of 3 institutions that's working on this. You know, so I'm at SU, and I can be sometimes a little bit more visible, but Mary's at ESF, Hyatt's at ESF. So the goal is for this thing not to be owned by necessarily anybody. If the state puts some funding behind it, they would own it. But these graphs you could pull out for your county dashboards for whatever, you know, and you can link to them. And so it's not an ownership thing that I don't see any issue with the ownership fees. I don't know who's paying for the web access yet, if it's still on your account, Mary, or if it's back on the Amazon web that I signed up for.
It's still on the, yeah, I mean, it's currently hosted on the Shiny Apps IO website. So it's just, yeah, it's on my group's dime at the moment, but that's okay.
Yeah, so ownership of the dashes, we want it to belong to the public, basically.
Yeah, I mean, I think having it be an open data initiative where, I mean, right now it's also, you know, I'd really like to have partnership development through our GitHub account, which is where the code for this thing lives. And then, you know, people who really know what to do about, you know, making everything look, you know, technologically fancy. I think that would be really great. So having as many eyes on this as possible, I think would be great.
So this is Gary again. So if the public is looking at this map and they see Monroe County is suddenly orange, who are they calling? I mean, they're not going to call me because I have no idea what any of, and the health department's going to need, there's jurists on it. They're going to need some guidance.
Yeah, that's a very good question. Very good thoughts, Gary. So we're pulling together. Yeah, so the health departments are going to be the ultimate resource for health. You know, the county health department is the authority, the public health authority in this state for everybody's county. And so the county health departments, in my opinion, should own the data, should understand the data, should understand how it's used. Our team is transitioning into a training and into where we want to train the local health departments how to use these data, how to use these dashboards. So yeah. Good thoughts.
So one more. So you'd indicated, I think yesterday, you were hoping this was going to be operational next week, right? Is that right? Did I hear that wrong?
We'd like to. Well, the plan is to work with folks like yourself, Rochester County, Monroe County, Onondaga County Health Department, other groups, Jefferson County, and
so they're going to be trained before next week.
We think it's that simple, yeah, that we could train them up in a couple hours. Yeah. For an epidemiologist to look at this is pretty straightforward.
Okay.
Yeah. So, and there'll be some growing pains along the way, of course, but we won't go live with the county's data until the county's ready.
Because our county has to get permission. I know that health department talk to their public information liaison. I'm not sure what the answer on that is. We have to get approval from higher up than me to put this on the dashboard. So I got a call in after this meeting to my boss to find out what the status of that is.
Yeah, so we'll talk offline, Gary, and we'll figure out what we need to do to make sure that that everybody's satisfied. We're not trying to circumvent anybody. We're not trying to jump the gun on anybody. So we just make sure that they're satisfied and get this out to help with the pandemic. So, Steve Bologna from Clinton has a question about a small sewer shed by Clinton, and Clinton's in Oneida County. And it's the only sewer shed, well, that and Hamilton College are the only sewer sheds we're monitoring in Oneida County. And so if you click on Oneida there, Steve, is it working there?
Sorry, the map is taking a
Yeah,
second.
that's Oneida there.
I got the detection trend, but
The map should come up.
the map should come up, yeah.
So then your map should come up there, Steve. And so hopefully we can get some more wastewater for Oneida County. There's also videos.
I know, I'm having trouble getting the map to load for Oneida.
But right now Oneida is Clinton, Steve. So
Yeah. Sorry.
So Kendra, thank you for your comments. She says the dashboard is amazing. You all have created a way to summarize the data that I've been trying to figure out. Yeah, let's work together, Kendra. We'll happily work with you. Steve says, if not owned by someone, will Quadrant be uploading data directly to the dashboard? That's the idea. That's the idea. And so right now, folks that are working with us have service agreements with Quadrant. And really the modeling and everything, we'd like that to go to the public. And so so we want to incorporate that. And so we're working through all that, all the challenges that'll pose. But the sample analyzed, as soon as Quadrant gets the data, it would update the dashboard on a daily basis with the new data. So, and it's a lot, and part of it, is to take me out of what's been happening to date is I've been sending out emails and interpreting data for you. And as this thing scales, I can't do that, honestly. I'd love to be able to, but to empower you with the tools where you understand what the data mean and what anybody on our team would think in terms of what it means. So Bruce asked a question: if the community were to want to use the info from the dashboards to inform public outreach, admonishing residents to improve mask use and distancing, do you have any recommendations for what types of readings or trend changes should trigger that? That is, how do we avoid the problems that came with the color-coded threat level announcements after 9/11? So good question here, Bruce. And I was not in New York during 9/11, so I can't talk about that reference. I don't know, Mary or Hyatt, if you followed that. We're working on building out these use cases. So Madison County just sent out a press release on a rise in transmission as observed in the wastewater to the village of Cazenovia. And that was released yesterday. And so that's out there. You can take a look at it. The state health department in Ohio has a whole host of resources for local health departments, mayors, and folks to engage the public with this. And so we'll be working to build that use case data. Now, in a place like Cortland County, where presumably the transmission bled over from the university into the community at some point, it can be tricky to identify at what point you should tell people or alert people that there's a rise. I think suggesting that there's and so I think we need to learn and we need to try and practice a little bit. So more to come on that and any help that others have in that regard. So.
I'm not getting the shape files to load for Oneida, so I must have an issue, a bug somewhere. Sorry about that.
Yeah, Steve, maybe we never got shape files for that sewer shed, and that might be the reason. But we'll double check. We'll circle back to that.
Yeah, I can figure that out.
Yeah, and we can also just use we'll figure that out maybe with a circle or a pin to signify Clinton. Go ahead, Mary. Sorry.
I guess just it looks like some of the questions are slowing down a little bit, but I mean, some things that are on our list that didn't make it into this release are things like temporal activity or ways to look back into interactivity rather to, ways to look back in time and see what was going on and like review responses and stuff. We, incorporating did like a lot of things you're talking about related to, okay, so I see this change and what's the decisions that are on the, on the plate that you could possibly choose from. So, trying to help with that type of interpretation is on the list.
Yeah. And Chris Wright asks if the info is useful for a geographically large county where sampling is only performed in one specific city in the county. It's a good question, Chris, and it changes based on the county. So if you have a highly concentrated population of the county, right? So say like this, the county of Albany, the majority of that population is in the city of Albany. And so then if Albany wastewater treatment plant is sampling, right, on a regular basis, that would give a good county level trend, a good estimate of trend of the county level transmission, because we don't expect transmission to arrive and stay and spread in these smaller rural communities. They'll come through and kind of blow up into these little clusters or not. Now for a county such as, such as Oneida, right, where it's a much more dispersed population, there's not a single population metro, then it makes much less sense to have a county level trend. And so that's one thing we would like to code out on the dashboard. But ultimately we'd like all the communities in a county to join in and to get wastewater surveillance going in their county. And then we create what's called a county harmonization model. And we give an understanding of transmission trend for the entire county. Now, if one area is blowing up and the others are fine, that might show that it's kind of stable or flat, but you can then click on the county and see the different sewer sheds and whatnot. So the more communities that build into this system, the stronger it will be and the more useful it will be.
So did I hear, I'm sorry.
Go ahead, Gary.
So did I hear you say that Quadrant will upload the data based on service agreement?
So Dr. Chen Du just stated that Quadrant will provide the backend data for the dashboard, but the specific data will only be available for the individual counties. Right, and then we'll work with you, Gary, to make sure that everything's clear before Monroe County or any, and this goes for everybody that's working with us. We'll make sure that you're comfortable with it going public before it's public.
Okay.
Right now we're looking for some.
We don't have an agreement with them. All we're doing is paying them through a secondary agency. So that's
yeah. So the agreement then would probably be with us, Gary, and
okay.
We'll work that out. Okay.
Katrina
Korthwacher from University of Rochester. She posted a link in the chat to the Ohio State Department of Health toolkit. That's the how to communicate information around wastewater surveillance. And Erica Bird from Madison County says that's where they pulled their information for their press release. Frank, yes. Sorry that. And if anybody, well, let's see. Let me find you, Frank. Frank, I don't think I have you muted. I think your audio is not connected. Unless are you calling in on the phone? All right, let me get your number. Oh. Are there any other questions before we close out? Steve, you'll still get the data. You'll still get the data. Nothing will change in terms of the data reports that you're getting. So that's a good question.
I'm happy to add anybody to, the approved list to be able to access this website. Right now it's on lockdown, but if anybody wants access, in this group.
Yeah. All right, so thank you everybody for your attention, your time as we kind of went through this. We hope to keep this conversation going a little bit. We'll be reaching out and we'll go from there. So stay safe.
Take care.
Thank you guys for presenting. Really appreciate it. It's great work.
Thanks.
Thank you very much. Thanks, David. Thanks, Kyle.
Thank you. Thank you.